it. All right, so it says our objective today is to determine whether 3 lengths could be side lengths of a triangle, and given 2 side lengths, I can find the range of possible lengths for the 3rd side. So that is our objective for today. All right, so it says Martina is building a wind chime. She has pieces of metal pipe that are 2, 3, 4, and 5 inches long that she is going to use to make a triangular top for the wind chime. Which combinations of 3 lengths will not work to make the top? So basically we want to make triangles, right? So I'm going to create a table. All right, so piece number 1, piece number 2, piece number 3, and does it make a triangle? So that's what it's going to look like. All right, so we have 2, 3, 4, and 5. So the lessons are in Into Math, but you have to go up at the top where it says Discover. So I don't assign the lessons, but they are there. So when you log in, you got to go to Discover and then to the chapter that we're on. Okay, but they are in Seesaw. The lessons are in Seesaw. And the lessons are in your daily agenda. I do attach them there as well. So if you want to download them and print them, you can do that. All right, so we are going to try the first triangle with the side lengths of 2, 3, and 4. Okay? So at this point, guys, all you're really going to need is like a ruler or a straight edge. Okay? So you can use the inches side if you want. That just means your triangle is going to be huge. So you would need to use a different paper to draw them, because you're going to have 4 different ones. So what I suggest is that you use the centimeter side. Okay? And looks like I'm going to need a different ruler because this one is not very clear for you guys to see. That just means the rulers are well used, right? Okay, so hopefully you can see the numbers on here. So I'm just going to do centimeters, just so I can get the triangles all on my paper. Okay? So I'm going to make the 4 be the base. So I'm going to draw 4 centimeters. Okay, so there's my 4 centimeter. And then I'm going to do a 2 and a 3. Now, I'm going to be honest with you. This is not easy because what happens is you have to slant them so that they would fit together. So, for example, here's my 3, right? So if I draw my 3, and I'm going to draw it lightly, because then I got to come back and draw my 2, and as you can see, it's not going to meet. So I'm going to lightly draw my 2. So now that kind of tells me where I need to go back and slant my 3. So I'm going to go back. So this is my 4. So I'm going to go back. Here's my 3. And so now you can see I can slant it to make it fit that 2. And as you can see, I was still off. So here's my 3, there's my 2. Okay? So this is my 3, this is my 2. So it's kind of working with those slants. Okay? So this one, does it create a triangle? Yes. Okay, so then we're going to move to the next one. So we're going to do a 2, a 3, and a 5. So I'm going to make my 5 the bottom again. It's just easier sometimes to make the longest one the bottom. All right, so I'm going to do 5 centimeters. So there's my 5 centimeters. And then we're going to have to do the same thing with the 2 and the 3. Okay, so I'm going to kind of do my 2 first. Like I said, it doesn't really matter. So there's my 2. And here's my 3. Okay, so here's my 3. So hopefully you can see that no matter how I slant my 3, right, I'm never going to be able to meet that 2. The only time I'm going to be able to meet the 2 is if I create a straight line. And at that point, it's not a triangle, it's a straight line. Okay? So I'm just going to, at this point, just kind of draw a 3. So that you guys can see that it doesn't work. And I'm going to go to my table and I'm going to write a no. Okay, and I can zoom out if that helps. All right. So let's try a 2, a 4, and a 5. And then my last one is going to be a 3, a 4, and a 5. All right, so we're on this one, the third one. So once again, I'm going to make the bottom a 5 centimeters. I'm going to move it down a little bit. Okay, so 5 centimeters. So I need a 2 and a 4. So let me draw my 2. And then I need my 4. Okay? So as you can see, as I keep rotating it, so as you can see, I may need to redo my 2 because I'm overshooting the 2 that I've drawn, right? So let me lightly draw the 4 and then go back and redraw my 2. So this is why I say, guys, it's not as easy as it sounds. So there's my 2 right there. Okay? So 2, 4. So then that would be a yes. And then the last one is a 3, 4, and 5. So draw that base as a 5. And then it doesn't matter which side's the 3 and the 4. Okay? So I'll do my 3 over here. I'm going to do it lightly because I may have to erase it. So this is my 3. And then come back and do, sorry, there's a bug in here. Wow, I don't know if I could do that again if I tried. No, it's a little bit too long, isn't it? So I'm going to have to redo my 3 just a little bit. Maybe too high. And then my 4. Go away, you stupid bug. Alright, so there we go. So 4 centimeters, 3 centimeters. So that would be a yes. So the only one we don't have that does not work is a 2, 3, and 5. Okay? So do I need to pause for a second for those of you that are drawing and writing to get them done? Yes, no? Alright, so I don't hear anybody, so I am going to move on. Oh, there we go. Now I hear somebody. Okay, so I see a no. Okay. So the turn and talk says, what do you notice about the set of links that did not make a triangle? So what do you notice? So the one that didn't make a triangle, what do we notice? All right, well, I can tell you what I noticed. I can notice that the two sides, 3 and 2, add to 5. The longest side is also 5. Therefore, it did not make a triangle. Okay? But if you notice, if I come up here and I do 3 plus 2, I still get 5, but the longest length is what? Longest side is 4. Okay. If I do this one, 4 plus 2 is 6. And the longest side is 5. So So what do you notice about the two shorter sides? What do you notice?
What do you mean by that, Mr. Lavelle?
So if my so this is my shorter side, right? 3 and 2 is shorter than 4. 3 and 2 is shorter than 5. 4 and 2 is shorter than 5. 4 and 3 is shorter than 5, right? So these are considered the shortest side. These are considered the longest side. So what do you notice when I add the two shorter sides? What do you notice versus the longest side?
You get 5, but the long ones you get 6 and 7.
Right, okay. And so these made a triangle, right?
Yeah.
Did this one make a triangle if it was equal?
Yeah, it would.
So this one made a triangle if my two shortest side added together gave me 5.
Oh, okay, I get it now.
So Hillary said no, it wouldn't. So that is correct. So this is the rule that you need to remember, guys. This is the rule. So the sum of the two shortest sides must be more than the longest side. Okay? So that is the rule. The sum of the two shortest sides must be more than the longest side. So I'm going to highlight that because that's important. Okay? So that means I need to add them, the two shortest, and if 6 is larger than 5, then I know it's going to be a triangle. I don't even have to draw the triangle. All I need to know is the rule. So if I add the shortest side of 4 and 3 and it adds more than 5, then it's going to be a triangle. Okay? So that is the rule that you need to remember. Okay, so hopefully you guys are kind of starting a rule sheet because there are a bunch of rules that we're going to learn as we go along. All right, so do I need to pause? All right, Hillary said no. All right, so we're moving on. So it says, can you draw a triangle with side lengths of 3, 4, and 8? There are different ways to model the situation and investigate. You can use thin strips of paper to cut the correct lengths, or you can use tools such as a ruler and a compass or geometry software. Use the longest side of your model as the possible base. Use your model to review the shorter side to view the shorter sides in different positions. Can you draw a triangle? If so, draw one. If not, explain why you cannot. Okay? So what did we just say? So this is A. So we're going to take the shortest side, which is 4 and 3, and we're going to add them, which is what? 7. Is that longer? Is that more than the longest side? So is 7 more than 8?
No.
No. So 7 is less than 8. So will not make a triangle. It has to be larger than the third side. Okay, so it says repeat part A using the shortest segment as the base. So what they're saying is on our first one, 8 was the base. Okay, so now if I rearrange it and I put 4 here and I put 8 here and I put 3 here. Oh, that's not 3. It should be 4. Oh, wait. That's right. Okay? So, even if I do 3, right, and if I put it this way, it's not going to be long enough to reach the 8. So, in B, it's the same thing. The 3 units is too short to reach the 8 units. There's no way that that's going to reach that, no matter how I slant it. And the reason why is because of this rule right here. Okay? 4 and 3 are still considered the shortest side. All right, so then C says complete the statement describing the relationship among the 3 side lengths that do not form a triangle. Use less than, equal to, or greater than. So once again, the sum of the lengths of the 2 shorter sides is less than the length of the longer side. So therefore, it will not work. All right, so let's look at number 2. Can you draw a triangle with side lengths of 3, 4, and 6? So it says, use the 6-unit segment of your model as the possible base. Can you make a triangle? If so, draw it. If not, explain why you cannot. All right, so 6 is going to be my base. So first of all, let's use our rule. So 3 plus 4 equals what? 7. Is 7 greater than 6? It is, so we know it's going to create a triangle. Okay? All right. So I'm going to use my centimeters again because that's just the easiest thing to use versus the inches. All right, so 6 centimeters. All right, and then I'm going to put my 3 on this side. So once again, I'm going to lightly do that because I may have to move it. Okay, so this is my 3. And then my 4, ooh, don't have to move it too far, right? So there's my 4. Didn't have to move that one. Sometimes I can get them right. Okay? So there's the first one. So that was a yes. So then on B says, use the 3 unit segment as the base. Okay, so now instead of 6 at the bottom, I'm going to use 3. Nope, wrong thing. So 3 centimeters. And now I'm going to use my 4 and my 6. So what happens now is this is going to give me an obtuse. Because if I do my 6, right, it's going to be way up there, no matter where I slant it. Okay? So I'm going to draw, I think, my 4 first, and it's going to be an obtuse angle. So let me, I don't know, I'm going to try it here and see if that works. I may have to slant it a different way. So there's my 6. Yeah, I'm going to have to go just a little bit different. Alright, so there's my 6. So as you can see, I need to move my 4 just a little bit, I think. Let's see if I move my 4. Oh, that's way off. Alright, and then I'll have to move my 6 again. So once again, it is a challenge to get this right. But there I go. Alright, so this is my 6. And this is my 4. We know it's going to work, right? It has to work because the 2 smallest are still larger than the 3rd. So it shouldn't matter the way I move it. Alright, and then the next one wants us to do a 4 segment at the bottom. So there's my 4. And then I'm going to do a 3 and a 6. Okay? So once again, because that 6 is so long, I'm going to have to, it's going to be an obtuse angle. So let me see if I can draw my 6. And it's going to go into the other one, which is okay. So there's my 6. And let's see. So I'm going to need to slant that one like this and definitely make my 6 slant differently. So there's my 3. So my 6, let's see if I can get it. Ooh, close. Okay, so let's see. It'll touch. Yep. Alright, so 6 and 3. Okay, so I want to show you something. Alright, so if I take, this is called parchment paper. So your mom uses it for cooking, but I can use it for math as well. Alright, so if I take this and I draw that original triangle, right? So this is, so this was my 6, my 3, and my 4. So if I take this triangle that I drew and move it around, right? So I'm going to match up. I'm going to flip it. So here's my 6. There's my 4. And there's my 3. So this is the original triangle. All I did was just put it right on top of the second one I drew. Okay? Now if I go down here and flip it. Oh, hold on, let me focus it. Come on, focus please. What do you see? There's my 4, there's my 6, there's my 3. And I slide it, and it goes right on top of that other one. So, what do you think this rule is? Anybody want to take a stab at it? All right, so this rule when given 3 side links, we can let me spell only wrong. Only create one unique triangle. Okay? So that is the rule. When you are given 3 side links, we can only create one unique triangle. So as I showed you, I drew the same triangle here, and all I had to do is just flip my paper around. So it is technically the same triangle. All right? So it says, are the triangles in A through C alike? Well, we already know that. They are the same triangle, just flipped around. As I showed you, right? I copied it, I traced it, and I flipped it around. So, complete the statement. So we know the rule. The sum of the lengths of the 2 shorter sides is greater than the sum of the longest side. We know it has to be greater than. So, repeating the rule, complete the summary of what you discovered so far. So we know sorry, I got people dropping out of the meeting. Let me download my attendance so I know who's leaving. All right, so if you add A and B is equal to or less than C, the segment cannot form a triangle. If A and B is greater than C, this segments form one triangle. Okay? All right, so now we're going to move to what is a quadrilateral. Well, a quadrilateral has 4 sides, and it has a rule as well. So our 4 sides are 2, 3, 4, and 5. Make and use a model. Can you connect the endpoints to form a quadrilateral? If so, draw a quadrilateral. If not, explain why you cannot. Okay? So, I'm going to use my first, I'm going to make my first one. And I'm going to make the bottom be the longest side. So I'm going to make it 5 centimeters. And remember, a quadrilateral is 4 sides, guys. So 5 centimeters. Okay? Then I'm going to kind of do like this one is. I'm going to make that one 4, so I'm going to do it over here. So there's my 4. And then my 3 is going to have to be a little bit angled up if I want my 2 to reach it. Yep, so 2, 3, and 4. Alright, so guys, just kind of do the best you can. I know this is a little hard to draw. And this one is 5. So, we know it can work. Alright, it says, using the same side lengths, can you make a quadrilateral that is different than one you drew in part A? If so, draw it. If not, explain why you cannot. So, I'm going to still use my 5 on the bottom. Move it down some. And guys, I know it's getting close to time to leave, but we got about 4 minutes. Okay, so there's my 5. So instead of slanting it so much, I'm going to probably do it less of a slant. And then what I'm going to end up doing and having to do is probably slant my 3 a little bit more. And then, yep. Slant my 3 a lot more. Ooh. Alright, so let me do my 2. So what I did was slant my 4 too much, I guess. So let me redo it. And that should be my 4 right there. Yep, and there's my 4. Alright, so here's my 4, my 3, and my 2. So as you can see, a little bit different, right? So, it says make a conjecture about the number of quadrilaterals that can be made using 4 different segment lengths. Support your conclusion. Okay? So, hopefully you notice that the angles change, right? So the angles change, but the sides stay the same. Okay? So we can make infinitely many. Okay? So when given 4 links of a quadrilateral, you can make much more than one. Okay? So that is the other rule. When given 4 side links of a quadrilateral, you can make more than one. So infinitely many. Okay? All right, so we will stop there and we will pick up from here tomorrow. All right, you guys have a great day.
Bye, Miss Lavelle.
Bye-bye.
Bye. Have a great day.
You too. Bye, guys.
Bye, Miss Lavelle.